Example 1. Find the exact value of each expression. Do not use a calculator. So part A, we want to find 2 sine 45 degrees plus 4 cosine 30 degrees. So because we want exact values here, and we've got a 45-degree angle and a 30-degree angle, we can draw our two special right triangles to help us find these two trig values, the sine 45 and the cosine 30. So we can draw a 45, 45, 90 triangle. So we want to be able to sketch these easily, and we know that that's an isosceles triangle. Two angles are the same, so two sides are the same. So if we have 1 and 1 here, then the third side, the hypotenuse, would be radical 2. And then if we draw a 30, 60, 90 triangle, it doesn't matter if these are to scale here. Obviously this one would not be an isosceles. So if here's 30 degrees and 60 degrees, so we know the sides here. The shortest side is 1 because it's opposite the smallest angle, the 30. And then the next largest is radical 3, opposite the 60. And then the largest side is the hypotenuse, which is double that short leg, which is 2. So once we have these sketched, we can actually do all of these problems here very easily. So when you're doing your homework, I would sketch these out and then use them to do the problems. And then on the final exam, again, I would sketch these on your paper as soon as you get your paper, and then you can have these handy if you need to use them. Okay, so part A, we want 2 times sine of 45 degrees. Okay, so 2 times, now we want sine of 45, so if I use this 45, doesn't matter which one. Sine is the opposite over the hypotenuse, so the opposite is 1 and the hypotenuse is radical 2. So I want 2 times 1 over radical 2 plus 4 times, now I want cosine of 30. So cosine is the adjacent over the hypotenuse. So here's my 30. My adjacent would be radical 3 and my hypotenuse would be 2. So my cosine will be radical 3 over 2. So if I simplify here, if I multiply, so this will give me 2 over radical 2 plus here 4 radical 3 over 2, the 4 and the 2 divide out. So then I'll just get 2 radical 3. And we like to rationalize denominators. So I'm going to multiply by radical 2 over radical 2 here. So I will get 2 radical 2 over 2 plus 2 radical 3. And then those 2's divide out. So I will end up with radical 2 plus 2 radical 3. Okay, I'd like you to try part B on your own. Let's jump to part C here. 4 plus tangent squared of pi over 3. So notice the squared is on the tangent. So that means that you're going to square the quantity. Once you find tangent of pi over 3, you're going to square it. We're not squaring pi over 3, we're squaring its tangent value. Okay, so pi over 3, we need to be able to recognize that that is in radians. So if there's no degrees on it, we assume it's radians. So we know that 180 degrees are equal to pi radians. So if I have pi over 3, and I want to convert that into degrees, so then I just multiply by 180 degrees over pi radians. So the pi's divide out, and I'm just left with 60 degrees. So if we want to note on our triangles here, so 60 degrees is equal to pi over 3 radians, and then 30 degrees is going to equal pi over 6. And just to help you remember, pi over 6 is smaller than pi over 3, and 30 is smaller than 60. And if it's 30, 30 obviously starts with a 3, but in radians it's pi over 6, and then it's swapped here. For 60 degrees, 60 obviously starts with a 6, but in radians it switches to a 3 here. Okay, so if we want tangent of pi over 3, here's our angle we'll use. We want the opposite over the adjacent, so opposite would be radical 3, and the adjacent would be 1. So I'm going to fill in here 4 plus, and we just found that tangent of pi over 3 is radical 3. And I'm going to square it because of this squared right here. So if I square a square root, that just removes the radical and gives us the radicand. And then 4 plus 3 equals 7. And I'd like you to try part D on your own as well.